All right, boys and girls, we're going to look at a lesson now that is called parts of a group, or it's multiplying fractions times a whole number. And so, probably the easiest way that I could explain this to you, and this is kind of how I describe it in class, is when you think about parts of a group. I always tell my kids, we'll think about a group. For instance, think about the classroom that you're sitting in. So you're sitting with a group of kids, and no matter how many's in your classroom, I mean, there's a group of you there. Or maybe think about sitting in, or maybe even standing down in the gym if you were in a PE setting and you were about to play a game and coach split you up into teams, and so he put you into teams, so there was a group, and then he split you up into teams to make the teams even. So as you're learning this math, just kind of think about that in the back of your mind. Think about a group, meaning you've got a group of people and you're taking a fraction of that group of people and splitting them up. Okay, so this first one is 1/2 of 16. Well, first off, when you see these problems, especially in fifth grade, when you see a fraction followed by the word of, so 1/2 of, you need to start thinking that really that word of means that you're going to be multiplying. So I think most kids, though, that see this and they see 1/2 of 16, I would hope that they would just maybe use some common sense and go, okay, well, what is half of 16? And hopefully kids would know that that's just 8, because half of 16 is 8. But we're going to see it a little bit differently. I think we're still going to get an answer of 8 here, but we're going to see it in a model, and we're also going to see it using an algorithm. So watch how both of these kind of start gelling together, and you can kind of just put it all together. So this is kind of how I would teach this example. So picture yourself with, maybe you and 15 other people in a room. And the teacher comes in and says, okay, let's take half of you and let's put you into two separate groups. So the problem here is 1/2 of 16. Well, if I look at my model on the right side of the page basically is just an array, and it's just a 4 by 4 array. And so what I could think about here is I could use this array to find my answer. I could simply just go and take half of it. And so I could look at it and go, okay, well, there's half. If I just split it in half, I could take half of those dots, or what could be people, if I wanted to model that, and I could count my dots there, and I would count 1, 2, 3, 4, 5, 6, 7, 8. My answer would just simply be 8. So that's pretty easy. It's an easier example. Halves are kind of friendly, so halves are easy to use. 16 is not that big a number, so that's pretty easy to spot. But let's talk about how you could reach this answer using an algorithm, or using it without a model, or using it without, a pretty friendly problem like half of 16. So what I'm going to do is I'm going to set up a problem underneath. I'm going to write 1/2. Instead of the word of, I'm going to write times 16, because of means we're going to multiply. But what I want to set up is I want to set up 16 as a fraction. And so I'll usually ask my students in my class, well, how would you set up 16 as a fraction and it still stays 16? Well, the only way that you could, well, there's several ways you could do it, I guess, but the smartest way, or the easiest way to do it, is just to think, okay, well, what if we put 16 over 1? Well, 16 over 1 is basically 16 divided by 1, because that bar means we're going to divide. 16 divided by 1 means we have still 16 wholes. So if we were to do this problem now and multiply these two fractions, multiplying fractions is really simple. All you do is you just multiply from left to right, and you multiply your numerators and you multiply your denominators. And so if you multiply your numerators, you're going to get 16, because 16 times 1 is 16. If you multiply your denominators, you're going to get 2, because 2 times 1 is 2. And then now you're left with 16 halves. Or the reality, 16 divided by 2, because again, that fraction bar that sits there is just a division symbol. So 16 divided by 2, or the improper fraction of 16 halves, is really 8 wholes. And then now we can see it several different ways. All right, this is just a new problem, 2/3 of 15. So I could think, one, I could use the picture for this to find my answer. Two, I could use the algorithm and just go solve it mathematically. Or possibly a third way could be maybe just thinking about this in my head. I'm going to go picture first on this one. So picture, what it gets a little bit tricky here. This is what my students have struggled with in the past, is you really, when you look at these, you have to train your eyes to look up and down, or train your eyes to look left and right. So I'm going to change the color here, and I'm just going to draw some arrows. And in red, I'm going to draw an arrow kind of looking left to right. And then in blue, I'm going to draw an arrow looking up and down. And so what I see, and I don't know if you guys see it, but when I look at this model or this array, I see two things. I see thirds, but then again, I also see fifths. So see if this makes sense to you. Train your eyes to do this. Look at it going up and down. So if I look at it going up and down, so I'm going to go back to my blue color here. Whoops. There we go. If I look at it going up and down, if I'm going up and down with my eyes, I see fifths. In other words, I see a fifth here. I see another fifth here. I see a fifth. I see a fifth, and then I see a fifth. So basically, if I look up and down, I see 5/5. Okay, well, that's one. If I look right and left, so I'm really focusing on my eyes going right and left, then I see thirds. I see a third there, and then a third there. So what I have to train my eyes to do and to really think about is, okay, well, what do they want on this problem? They want 2/3 of 15. Well, they don't want fifths. They want thirds. And so if they want thirds, then I'm going to go look for thirds. And so in other words, on this problem, I don't really want to look up and down. I want to look left to right. And when I look left to right, if I go grab two groups, 2/3 of 15, my answer is there. I would count my dots here in this case. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. My answer to this problem should be 10. Okay, now let's use the algorithm. Let's just say that picture's not really, I'm not really sure if I understand that just yet. Remember, your algorithm could always save you. In my opinion, you can always fall back on your algorithm. So if you know that the problem is 2/3 of 15, then you're going to set up 2/3 instead of multiply. We're going to write 15 over 1. We still want it to be 15. And we're just going to multiply. So we're going to multiply here. 15 times 2, or 15 doubled in this case, would be 30. 1 times 3 is easy. That's just going to be 3. And so now we have the improper fraction or division problem, 30 divided by 3, which then gives me 10. All right, so there's two ways there that you could find the answer and both find 10. The other way that you could find the answer, and you have to watch for this, and I got to admit, sometimes I will allow this and sometimes I won't, but, you know, I think it's smart. I think this is you're using your math skills when you do this because you're using your number sense here. But what I'm going to do here is I'm going to change colors just to kind of show that I'm doing something different. I'm going to go back up to the original problem. 2/3 of 15. Well, what you could do is you could see if there's a relationship between the numerator and the whole number. So in other words, what I mean by that is when I look at 3 and 15, I know that there's a connection there. I know that 3 could equally go into 15, and I know that 3 could equally go into 15 5 times. So what I'm doing, though, is in my mind, I'm telling myself, okay, well, if that denominator can go into the whole number, then basically what I'm finding out is I'm finding out what a third is of that whole number. And so it's kind of weird, but if you think about it, a third of 15 is 5 people. I mean, or 5, whatever. I always think about people. That just makes more sense to me. But like if you had a group of 15 there, and let's say you're in that gym and coach comes in and is like, okay, you got a group of 15. All right, break into 3 equal teams. Then that wouldn't be too hard to do that. I mean, kindergartners or first graders could probably do that. You'd split up and every team would have 5. Well, okay, so if I see that connection there, well, they want 2/3 of 15. So basically, they want 2 of those groups of 5. And if I have 2 groups of 5, that's simply just 10. And so there's what different ways to solve these problems. You have to kind of be prepared for, I think, at least from my experience and my students, the more ways that you can see this and learn it, the better off you're going to be. And it's like, okay, well, hey, if I know just one way, that may not be enough. Know it multiple ways. All right, this next example here, I'm going to go a little bit faster, is 4/6 of 18. So I'm going to start with algorithm, on this one. Algorithm is going to be 4/6 times 18 over 1. So what this one's going to do is this one's going to basically, make me work a little bit more because I'm dealing with some facts that I may not know. And so on this one, I would expect to see a kid write this out to the side because I don't expect too many to know their 18s. If you did, it's not, I mean, that's a good thing to know them, but I'd rather see a kid work it out so they don't make a mistake because 8 times 4 is going to give you 32. 4 times 1 is 4, plus an extra 3 is going to be 7. So I'm going to have 72, but then I'm going to have 72 sixths. So basically 72 divided by 6 is what this is going to amount to. Well, this is now, I think, a doable problem mentally because it's a math fact. You should know this. Your biggest 6 that you should have memorized are your 12s. And so 12 times 6 gives you that 72. So I think this answer is going to come out to be 12. Okay, let's now look at just the original problem. Let's see if there's a relationship here. So my denominator is 6. My whole number is 18. So in my mind, I'm thinking, can 6 go into 18? It can, 3 times. And so I'm thinking, okay, if it can go in 3 times, then 1/6 of 18 is going to be 3. But I want 4 of them. So 4 times 3 should give me that answer of 12. All right, then the last one, if I look at the picture, if I look at the array here, then I have to really be careful. And again, I have to train those eyes or my eyes to go up and down and left and right. Well, if I look left and right, I see thirds. Okay, I don't want thirds on this problem. I want sixth. So if I look up and down, I think I see some sixth here. And if I go and circle it, I gotta make sure I've got it right here. Yeah, there's 4 groups of 6. Here's 1 group, 2 groups, 3, and then 4. And so again, my eyes are looking up and down. And so now, if I go count those dots, I'd have 12. So I could see it 3 different ways. All right, on this last page, I just wanted to throw this at you because sometimes, the arrays might be there. You might have the ability to look at an array to help you out. Sometimes they may not be there. Also, you might have some problems like this one where you're looking at something that does not have a relationship between the denominator and the whole number. In other words, 9 can't equally go into 20. So it could be an instance where you just really need to rely on your algorithm. And so the other ones have kind of been nice because they've all been kind of friendly answers. Something like this could show up where it says 4/9 of 20. Well, if that did, we're going to take the same approach. This way works every time. We're just going to go find out what the answer is. We're going to have to do a little bit more work. All right, so 20 times 4 would be your first step. Well, 20 times 4 is like 4 times 2 or 2 times 4, which is 8, but with a 0 behind it. So we're going to call that 80. And then 9 times 1 is 9. And so on this problem, I'm going to have to now think, what is 80 divided by 9? Well, If you know your nines, you know that you can't equally go into 80, but you can get close. 9 times 9 is 81. That's too much, so we're going to have to back off one. We're going to have to think, okay, well, how many times can this truly go in? Well, I think it can go in 8 times. 9 times 8 is 72. 9 times 8 is 72, so that tells me I'm just a little bit under, and I'd have to go and think about the difference between 72 and 80. The difference there would be 8. My denominator would not change, so I would have 8 and 8 ninths as my answer here. I cannot simplify 8 ninths, so I know that this would be a final answer. So that could happen. Most of the time, if you're thinking about parts of a group, you're going to probably come out with a whole number as your answer. But this is just showing you that it could happen potentially when we do some of these multiplication problems where all we're doing is we're multiplying. Maybe when we multiply, we end up getting a mixed number. It just depends.